Funkadelic Coders, it's Prop G, and our foray into funkiness will continue with Bring On to Func Part 2, where we'll cover scope in functions, global versus local variables, return values, best practices, and we'll end by presenting a challenge spanning multiple lessons. Let the groove continue with CircuitPython. So Codemeisters, plug in that Circuit Playground and spark up the pie charm, and if you're new to the playlist, here's where you can find all the goodness that brought us to this point. Now we're going to learn about modifying values inside of a function, and first I want to introduce a concept called scope. Now scope refers to where a variable is available and can be used. So either scope is global, it can be used everywhere, or it's local, it's only available where it was defined, like inside of a function. So in Python, if a value is defined inside of a function, then it's only available inside of that function. We say that it has local scope. The scope is local to that function. The life of the variable is local to that function. In this example, the variable local underscore variable is first used, it's defined or created, inside the function named first underscore function. Now when I try to print it inside of first function, I have no problem. But when I try to refer to it outside of first function, say inside this other function called second function, or outside of both of these functions, I get the red squigglies of anger. Python tells me that the value local variable is undefined in these statements because it only has scope, or it only lives inside of first function. Now let's contrast that bad boy with this variable here, global underscore variable. Since it's defined outside all functions, we say it's a global variable and it's available everywhere. We can print it inside both functions or outside of the functions. No red squigglies of anger here. Let's work through an example. So here I am with that one parameter playSound function that we saved at the end of the last lecture. Now the variable that we see here, path, is defined outside of the playSound function. So we say that it's defined at the global level and it has global scope. So any function that we write would have access to path, and in fact we see that we're using path inside of the playSound function. We haven't had any problem with that. So path exists here outside the function and here inside the function. But if we define a variable inside the function, it only lives or exists inside the function. It has a scope inside the function. The scope is local to the function. Try this. Inside the function, let's write local underscore variable, that's our variable name, equals, and how about the string, coder, comma, you are the coolest, exclamation point. And right after this line, let's say print, and between parentheses, we'll pass in local underscore variable. Now let's run the code. We see the phrase when the button is pressed, and it is true, you are indeed most cool for coding in CircuitPython. But what if we wanted to use that local underscore variable outside of the function? Like, let's say, after we called playSound in the first if statement in our while true down here. So why don't we add a print statement below this, and in parentheses we'll start to type in local, and oh, look at this. Code completion doesn't see it. And if we try to force this by typing in local underscore variable, we get the red squigglies of anger. Linger over the squigglies and we see unresolved reference. Unresolved reference is Python's way of saying, I don't know what this is. And Python at this point in our code doesn't know what the local underscore variable is because it was defined inside the playSound function. It has scope in the playSound function. It only exists inside the playSound function, not outside the playSound function. So we can delete this, it's not going to work. And it's a good idea to define variables inside of functions only if they're going to be used inside those functions and no place else. And it's okay to define variables outside of functions if you're going to be using them at the global level, and it's okay to refer to them inside of functions. Now there's another thing to be aware of with scope. Be careful of using the same names inside and outside of functions. If there are global and local variables with the same name, the local variable will take precedence. Let's try this. Rename the variable inside the function from local underscore variable to just statement. So it says statement equals coder, you are the coolest. And modify the print statement of the function to read print with the f string. Inside the function, we print colon and then curly braces statement. Now let's create a global variable outside the function that has the same name. Let's do it under path name. We'll say statement equals, in double quotes, dang, comma, you good. Now let's add a print statement underneath the call to playSound if button A is pressed. So we'll say print and then the f string. Outside the function, we print colon and then in squigglies statement. And we'll save and run. And let's press button A. And you see what happened? We have two variables that live with the same name, but the statement defined inside the function is the local one. So that prints out, coder, you're the coolest inside the function, while outside the function, the statement that prints is, dang, you good. That's the global variable. So now let's try something different to learn more about variables that are global in scope. If you want to change a global variable in Python, it gets a bit weird. First, let's delete the local and global statement code. There's some in the placeOut function, then up here by the path variable, and also a statement here in while true. And now, say we want to keep track of how many times a button was pressed. You might think we can do this. Create a global variable to keep track of button presses, times underscore pressed equals 0. Then inside the function write times underscore pressed plus equals 1. But look at this, we're getting red squigglies of anger indicating that we have an error. Unresolved references times underscore pressed. So here's the scoop. If you modify a value inside of a Python function, it thinks that that variable only lives inside of a function. The only way you can modify a global variable, and that's what times underscore pressed is if we declare it as a global variable inside the function before we use it. I haven't showed you how to do that yet, but it's just the word global, space, and then the name of the variable. Now the best practice is if you do this, that you do it just after the function definition statement, so you know when you look at a function if there are any global variables in there and what they are. But I'll argue that you shouldn't use global variables inside of functions at all. But first, let's make this work. So just under the function definition line, at the first indented item, we'll enter a new line, global space times underscore pressed. That declares the time pressed value as global. No more squigglies of anger. Then below times pressed plus equals 1, let's enter a print statement with an F string and double quotes, times pressed colon, and then in between the squigglies, we'll pass in times underscore pressed. And if we save and run, things work cool. The reason why modifying global variables inside a function is bad is because it reduces modularity and flexibility. The modification of the global variable is hidden inside the function, and sometimes in a more complex project, several developers are working on the same code. So one might be in charge of one function while another developer is in charge of another function, and if somebody modifies a global variable in one function, it isn't clear how this is going to impact the rest of the program and the other functions. Now, frankly, that's less of an issue in maker projects where one person usually writes all of the code and where there isn't much code to begin with. But most makers want to write reusable code so that a chunk of functionality can be quickly copied from one program and dropped into another. And modifying globals inside functions is bad here because the other project has to assume that there's a global variable that's been defined in the same way. So how do we write better code? We use arguments and return values. Let me show you how. First, let's delete the references to time underscore press that are inside this function, and we'll add a new value to the function definition. After the file name, I'll say comma press underscore count. Now, just like other arguments, we can use and modify press count inside the function, so let's do this. Press underscore count plus equals 1, and then we'll print the F string in between double quotes, press total colon, and then in between curlies, press underscore count. Now, if we modify the call to play sound and pass in the global variable time pressed, we're sending this value into the function. We extract whatever was sent in, but we don't change the global value. And let's run this and take a look at the output to make sure that we know what's happening. And for some reason, my board wasn't responding, so I just press reset and I can see it reconnected. So here we get press total equals 1 every time we press, because while we pass in 0 from global times pressed into the function and change the value passed in by adding 1 to it, so that value goes into press underscore count, it was 0, and then 1 was added to it, so press underscore count is 1, that press total isn't passed back out to times pressed. Times pressed remains unchanged. So these are two different values. So the question is, how can we take the value modified inside the function, the value from press underscore count, and then pass this back out to times underscore pressed? Well, we don't want to define a global variable inside the function, even though that would work, but we can use a return value in the function. Try this at the end of the function. So still inside the placeOut function, but outdented to the same level as this with statement, we're going to write the keyword return, followed by the value that we want to return, which is press underscore count. That's the value we just modified inside the function. Now, return needs to be the last statement that we execute in the function because it returns from the function. Any statement after return indented at the same level isn't going to execute. And now we're not done yet. We haven't done anything with the value that's being returned. But because we added a return statement, this function now returns a value. And for context, some functions return values. For example, the length function. If we say len, passing in the list named colors, that's going to return the length of the list. And some functions don't return any values, they just do something. So for example, if we say pixels.fill passing in red, that returns nothing, but it does something useful. It turns all of our neopixels red. Now in Python, we say a function that returns nothing actually returns none, but nothing shows up. Well, with a return value, our function returns something. So let's do something with it. We'll assign the value we get back to times_pressed, like this. Times_press equals this function call, because this function is now returning a value. So what's going on here? Times_press is going into the function via an argument. So the first time we go through, we pass a 0 up here. That value 0 is extracted and put into a local variable press count. 1 is added to press count, and this updated value hits return down here, and it's returned. So we get a number after this function call. It's assigned to times pressed. So after our first call to play sound, 0 goes in, but 1 is returned. That's assigned to times pressed. Then we keep looping through the while true loop. And if you press the button again, call this function again, 1 goes out of the function because that's the value of times pressed. It's modified in the function, 2 is returned, and that's assigned to times pressed. This passing a value in and returning a value is repeated over and over every time you press the button. That's the value of the return statement, and we're not using any global variables. So let's save and run. And it works, we're updating, nice. Let's save this as function-with-arguments-in-return-value. So you've got functions with arguments and return value, so you can refer to this if you need to as notes. And we'll return to code.py. And you know what? To get ready for our challenge, I'm going to open up our play sound function that we'd saved earlier. That's the function we're usually going to use when we want to play sound. I'll copy all of that, close this play sound window, and I'll highlight all of the code in my code.py, and I'll paste this over. And you'll want to use that code in the fidget.challenge. Now this is a big challenge that incorporates things over the past few lessons, and we're going to wait until the next lesson to show the solution for this. But here's the challenge, and I know you're up for it. When either button is pressed, play the splat.wave sound. Now when button A is pressed, turn off the prior light, if any, and advance the light by 1 in red. If you press B, turn off the prior light, if any, and backtrack by 1 in blue. Now I said if any because when the program first starts, no lights are lit up. That might be one of the harder things for you to do, and if that trips you up, try to get everything else and you can just start at 0. You see how we're moving backwards and forwards, red and blue, depending on which button is pressed? If the advancing light moves past light 9, then move it to light 0. If backtracking moves below 0, move it to 9. So the idea is the light would spin all around your circuit playground. Hint, you're going to need to use debouncing. And here's another hint. If you compare values inside of an if statement, here are the operators. So double equals with no space in between checks for equality. So for example, if you wanted to check if position double equals 0, that means you're checking to see if the position equals 0. It'll be true if it's equal to 0. It'll be false if it's not. And there are other logical operators that'll return true or false. You can check to see if something is less than a value, if it's less than or equal to a value, if it's greater than a value, or if it's greater than or equal to a value. And to show your knowledge of what we learned about functions and variable scope, perform this with a global value to keep track of the light position on your circuit playground and name that light_position, and a function named move_dot that takes in 3 parameters. Position, which will be the light position, direction, which will be either 1 or -1, depending on which direction the light should move, depending on which button was pressed, and color, either red or blue, and this function should return a value, which is the updated position, which you should use to update the light_position global value. Now this move_dot function should call the play_sound function to play the splat.wave, and it should handle all the light updates in the appropriate colors. When you're done, save as fidget-dot.py, and we'll compare answers in the next lesson. Now this is a big challenge. Feel free to go back and look at past code or review earlier lessons if you need to. Don't get discouraged by a big challenge. This is the way to ensure that you're learning, but I know you have what it takes. But in this lesson, we've had some extraordinarily big learning. You learned about variable scope, local versus global variables, the global keyword, why you might not want to use it, what happens if values inside and outside a function have the same name, function arguments and return values, and various operators to test for truth or falsehood inside of an if statement. The double equals, the less than and equal, greater than and equals. So Pythonistas, code those funky functions and drop into the next lesson after you've coded the awesome so that we can compare answers. Hack on!